Hello, everyone. I wanted to do a quick webinar talking a little bit about some experiences I've had on standardizing custom. I think today a lot of people think of me as a manufacturing person here at DS because that is the focus of the task that I have. However, in previous lives before Dassault, I spent a fair amount of time in building components, working together, designing, engineering, and enhancing products. And one of the ones that I want to talk about today is the job that I had before I came to Dassault, where I worked for a company building recycling equipment. And we went through the entire process of going from custom to standardized custom, and then along that journey adopting some technology such as the 3D Experience platform to connect what we were doing in Solidworks and simulation and PDM and all those other components together to really streamline the process and the throughput. And so what I want to talk about today is, oftentimes when in manufacturing we talk to people and we talk about plant layout and how we fit everything in, the common thing we get back is, yeah, that sounds really great, but we're custom. And, my experience of being custom is you can still standardize custom. So let's talk a little bit about that today, and I'll talk about my experiences and my opinions on how this functions, and then also a little bit about how we were trying to use the right tools for the right job, regardless of what was going on around us. So let's dive in and talk about this. So traditionally where we would end up is we were uniquely custom in the recycling industry. Lots of the people that we partnered with or competed against, they would design a recycling plant and then they would tell you to build a new building around that plant, and everything just fit perfect because they designed a style of recycling plant that fit in a 40 by 60 or 80 by 30 or whatever it was going to be. The niche we had was we would make custom systems to fit in any type of building. So it could be a 150-year-old building that's all brick and it's in a part of town that maybe is no longer popular and they want to do recycling out of it. So our challenge was always, hey, we got to get 20 tons per hour of goods recycled to do, corrugated, different color paper, ferrous, non-ferrous metals, all of those things. But it was always in a challenge like you see in the image below where it's like, okay, this is an existing building, there's vertical supports everywhere, but yet we still have to create enough throughput to drop off, recycle, and ship out 20 tons per hour in 4 by 4 by 8 foot bales. If you're from the Midwest like I am, you can think of it like a big square hay bale out in a field. It sort of looks like that. So our challenge was always everything we do is always going to have a unique twist to it. And when I started there, we were working on a big project, and the custom thing was, sort of biting us a little bit because everything that we did was always one-off and unique, so we were always constantly changing. And when you start looking at bigger projects where you have 56 or 7 conveyors, you have 13 pieces of buyout equipment that you're going to put in, and you're trying to mash it into this building that's off out of square by 1.5 feet over 100 feet, nothing works as perfect as what you do in CAD. So one of the things that we went through, and I'll talk a little bit about how the process works, and then I'll show a little bit about how we transition and actually were able to improve not only quality process, but also shorten our time and provide a better experience for the customer. So when we look at a traditional quote, this would be sort of a layout that we would get, and honestly, this one's a little fancy because it already has all the other CAD stuff. Oftentimes it was, you'd go out the tape measure and you'd measure and you'd sort of get some space, and it's like, okay, we got to fit a conveyor in here, and it's got to do so much ton, and it's going to be a certain mixture, so that determines the degree and the angle and the nose over and all the other good stuff. So we would get something like this, and it would be like, okay, quote it. You're going to have a section of the conveyor that sits at ground level, so you can push into it with a bobcat or whatever it's going to be. And then that's going to take the raw material to be processed up to a certain level so it can be sorted out either by hand or through automation or whatever it's going to be. Now, if it's an existing system, we would get layouts like this because they basically want to replace an old conveyor with a new one. So you're space limited on everything. And keep in mind there's electrical and pipes and everything else because oftentimes these are in very short ceilings. So when we would get something like this, it would be like, okay, well, there's like 5 foot for a tail. There's 15 foot in the pit where they can push onto to load the conveyor. Then it's 20-degree angle. That's determined oftentimes by the type of material. Also the space height. We play with those numbers a little bit. You have an incline that gets you to a point. You have an equal opposite angle on the other side to dump out either level. Sometimes you dump out negative, but in this instance, it's equal opposite. And then you have a head section, which is a component for your rollers and everything else. And also the drive. So you would get something like this, and each one would come in uniquely different. The next one you get might be 10 foot in the pit, 32 feet in the incline, and the nose over and curve up would be 35 degrees. And you can start to see how it's easy to get in that mindset of like, okay, we're unique in everything that we do. That's just what we do. There's no way around it. We are custom. Don't talk to me about automation and standardization. I think we've all lived that lives in our engineering careers. So the way that we started looking at it as, okay, what are the components? So if we look at how we were quoting back then, it would be, okay, looking at the image on the left, we would have one tail section, we would have a lower pit section. We would take whatever that lower pit is, just divide it by 2. And the reason we would divide it by 2 oftentimes is because we have to stack these on a truck. And we also have to install them in the field. So we do concern ourselves with weight and how people can parse this up. Because oftentimes you're not going to come in with a big crane. Like in this instance of the existing building, you're going to be doing this with forklifts, more than likely. So we would create 2 lower sections at 7.5 foot. We create a curve up. We'd create the incline. We'd do 2 incline sections at 11.5 feet. Then we would do 60. And then we would have legs. We'd have pit covers. We'd have a transition. So when the material comes over the edge, it doesn't just fall all over. We're sort of funneling it. So that's how the quote would look. And you look at that and it's like, yeah, that makes sense, right? You would divide that thing up. When you're on the incline, you would do 2 at 11.5 feet. But you can start to see that although that would be something we could do in engineering, that makes it a one-off when it goes to production. So this job, we have to tool up and set for a conveyor. And then the next one that comes through, we might have different lengths, right? So although it's the same style of conveyor with the same parts, each one then becomes unique because of how we're handling it in engineering. And that is really just taking the distance divided by 2, figuring out what the weight is. Yep, yeah, they should be able to do that. It fits on a semi, good to go. Bob's your uncle. The challenge with this is then every job that comes through in the shop, we lose productivity because everybody now has to think, okay, that job was 11.5 feet. Now I got to rethink all my measurements for the next one, which is going to be whatever that's going to be, and so on and so forth. So when we start looking at this customization, we really become a victim of our own thought process of being customized. So what we started looking at was, okay, let's dissect what a traditional conveyor looks like. How does that fit, right? And so what we did is we started breaking it down into, okay, how many pieces do we have? Well, generally in a typical conveyor, like you see in the image, it's 54 structural angles, 28 pieces of square tubing, 216 sheet metal parts, 1 gearbox, 2 shafts, 4 sprockets, 96 pieces of plastic. And you start looking at that, and in the traditional method I mentioned before, each one of those things has to be touched every single time in engineering. Then it has to be touched in ordering. Then it has to be touched in cutting. And then it has to be touched in welding. And then it has to be touched in painting. And then we touch it the last time for putting it on the truck and then installing it. So when you start thinking about that, all of these components that you see, it stacks up. Because we've taken the route of, oh, we're custom. There's nothing, we're just custom. You can't do anything about it. We're custom. Well, as we started adding automation into our process, we took these numbers, we looked at these components, and it's like, okay, well, we know it's going to always be structural angles. There's always going to be square tubing. There's always going to be sheet metal. There's always going to be motors and sprockets and plastic and all those other things that go into it. And what we did is we said, okay, we've adopted Solidworks. We have Solidworks. We have this tool. Everyone is taught in a traditional method of you make parts, you put parts together, you make an assembly. Well, that creates lots and lots and lots of data. It also creates lots and lots and lots of references, which then traditionally slows down what you do. But everyone's taught this way. Well, we took it and we said, okay, we have this tool that has all this great capability. How do we use the tool like we would use a laser or a CNC press brake or a pen or paper or a tape measure? And what we did is we redid everything to be multi-body. And we also went and did and made them scalable so we can make quick adjustments to these components. So looking at that conveyor that we had before, and we look at the components, that conveyor that had all those things that I just rambled through really quick was really 14 parts, unique parts. So that was phase one. We go from hundreds and hundreds of items that are all referenced into an assembly down to 14 parts or Lego style blocks that we can put together. That was the first step in automation. Then the next step in automation we took was, okay, we got these 14 things. Can we start creating a standard? And what we did is we went out and spent time in the shop. And we looked at the equipment we had, and we also watched how people handled components. And that means, how do we move it around the shop, the raw material? How do we process the raw material? Where does it get stored? Do we have unique carts for certain things? Is parts falling off? How do people weld it together? How are they standing it up? What is the good and the bad of that? When it goes to painting, how do we hold the parts to ensure that the paint works in the way that we need it to work so we can get it on a truck in a timely fashion? And what we started to realize in doing those components is the best throughput we could have is starting to design to a standard that optimizes the ability to create components in the factory or in the shop. And the equipment that we had bought and added, we had a 5x10 laser. Then we had a 10-foot wide press brake. We went to a little bit smaller equipment, but equipment that was faster in producing goods. And once we started doing that, then we started looking at, okay, if we know that this is what we're built to handle, we can easily have one person at the press brake if we keep the size of material to a given rate. We keep the weight down on what we do. And then when they go to weld it, if we create things that are always the same for the most part, they can set up fixtures that allow them to easily place it with less thought and less looking at the print for each job that comes up. So what we started doing is, because of that, if you look at the BOM on the right, this is how we started moving once we had the blocks done in engineering and we did a study of manufacturing. And what we found is we were really efficient at producing 10-foot items all day long. 10-foot conveyor sections, 10-foot bases. We were really good at creating 5-foot tails, 2-foot heads. And then if we kept the curve up and nose over sections to standard specific increments that we commonly sold, we could produce those very efficiently, and people didn't have to think so much because it was the same repetitive process. So if you take the first thing we talked about and we take what we have here, what you'll notice in the new quoting system is we would create mostly standard components, and the only things we would have to focus on that would be unique would be 3 different items that were custom on this order versus a whole bunch of things that were custom and one-off. So because our ideal manufacturing process was 10 feet, anything less than 10 feet was easier because it was lighter and easier to handle and easy to move, easy to set on the cart to paint. So if we look at the lower pit section, instead of doing 2 7.5 footers, we would have 10 footers. And it became really common for us to have 60-inch wide 10-foot sections. We could actually, in slow time, stockpile those as needed because we knew more than likely someone's going to order a 60-inch wide conveyor from us, and whatever the unique piece is, there's always going to be a 10-foot section in there. Same with the incline, same with the head, same with the tail. And because we started doing that, the guys got really comfortable at building the same thing over and over and over. More importantly, it was easier for us to quote because we had a understanding of what a 10-foot section cost. So creating a quote like this was a fraction of the time it used to be. Creating the layout was a fraction of the time it used to be because remember those multi-bodied parts we had? We then just had a standard library of widths we sold with standard 10-foot sections. So when you go to do a layout here for like a quick layout for a customer, you would drop in the standard 5-foot tail, you'd drop in a 10-foot section, you would drop in 2 10-foot inclines, curve up, nose over, and the head, and then we could play with the angles, and what we would end up with is whatever that gap is. We take the measurement, and that's our new subsection conveyor. So instead of spending weeks, we could go to hours for quoting, but more importantly, because we were using standards, most of the prints were done. Most of the things were already pre-programmed. The shop was set up to handle those. We had material that we could run. If we created a conveyor section and there was something where somebody didn't like it because it was 10 foot, it wasn't wasted. We would just sell it on the next one we do. So even though every conveyor we do is custom, we have enough standard components that the only effort and focus is on the unique pieces, even though our bread and butter is making those 10-foot sections or the 5-foot tail or the 2-foot head or given angles of up, curve up and nose over. And so what that did is it freed up engineering to not get drugged down with doing mundane components. It allowed them to be really good at the custom, which is what we needed to hit. It also standardized how we loaded trucks because we got really good at loading 10-foot sections on the truck, and we didn't have to play Jenga with every truck that went out. Our installers in the field got better at installing because they were used to handling and working with 10-foot sections. So it wasn't like, boy, I wonder how we're going to pick this section up because it's different than the last 4 or 5 we did. It was, okay, it's just another 10-foot section, pick, go place it in there, bolt it all up. The last thing that we did also is we changed from I-beam legs to 4x4 tubing legs. And we did that because we built in a bunch of adjustment. So instead of creating one-offs, what we did is we created a standard adjustment that fit our angles so you could easily swivel the legs up or down, position them. It wasn't specific to a given angle because if the floor is wrong in the field and you make it for a exactly 20-degree angle, well, if the floor is off, then they have to shim and grout. If we make it a little bit adjustable, we give flexibility on the tilt and position. We also made them to where you could adjust the cross braces up and down. So if we missed a measurement in the field, they could move the cross brace to a position and have clearance underneath. And the last thing is we built in a screw adjuster. So if you had to adjust up or down, you didn't have to pick the whole conveyor up, change the bolts, and then drop it down and then re-weld it or cut it. We made them so everything was adjustable because we were, again, thinking of that standardization for manufacturing. How many different legs could I build that are the same? So when I go to do the custom order, for example, as you see here, this leg in the background is the same as this leg in the background. The only difference we measure is how long to cut the tube. And so it just is one cut difference, but how it's assembled, how it's welded, how it's placed is always the same within our facility. So when we start talking about customization and automation, what we're talking about is, yes, I'm talking about a single conveyor here, but when we start talking about the more advanced components that go into it, here are the things that we looked at in a summary, and then I'll show you an example of how this compounds, and then I'll end my quick discussion here. So a lot of times when we get asked, well, boy, I do all this stuff over and over and over, but we're custom. And my question is like, are you really custom, or do you make some custom components and everything else is standard? And if the answer is, well, we do it custom because of the scenario I explained up front, where that's just what we've always done, then okay, fair enough. It's custom, it's one-off, it's unique. But if you generally start digging deeper at what your core competencies are in manufacturing, what you'll probably find is there are lots of ways that we can reduce the waste of process by building the standard things that we're really good at, and then putting our key people that are like the best manufacturers we got in the shop on only building the custom. Everyone else can just focus on building all these standards and cranking them out. And my best manufacturers, my best people, I put at the custom, they put their energy into that. And then what I still get is a custom product for the customer. So I can say I'm custom, but as I'm producing it, I'm standardizing what I'm good at, and I'm only taking a small subset of my business and making it unique. So the questions generally asked, and what we went through just happened, is how do you produce products today? How do you do it? What are you good at? What's your core competency? Do you have people that struggle if the part gets over 6 foot long to form it? Do we have material handling issues because of the size of products we do? Could we break that down into sections to make it easier for an individual to handle it, make it repeatable? How does your product ship? As the things that we did, they always went on drop decks or straight decks or double drops, 53 footers. One project we did in New York had 30 some loads, semi-loads, hauled from us that were completely full. And so when you start thinking about how you're going to load it, unload it, handle it, the weather affects it, in our case, because they were so big on semis, how do the tarps beat on it? Thinking about how it ships and how effectively you can load and unload and mark things, right? If the product's assembled on site, what equipment do they use? As I mentioned, most of ours were in tight, small spaces, so forklifts were used, okay? How do we build something that's easy for them to move with a forklift? What's the talent level of people installing? If you have installers that go out, are they just general installers that's hired by the local team that may have never used your product? If they haven't, then what we have to do is we have to create a scenario where we install to a point where they can't get it wrong. They can be irreversible. It doesn't matter if they put it in backwards. The fasteners and hardware are all the same, which gets me to the next thing. Can we standardize the processes and the hardware? One of the big things we went through is like when we went to tubing and we relooked at how we did all those sections, we switched everything to a standard hardware, a standard grade 8 hardware. No matter what it was, even if it was a little overkill, it all used the same diameter hardware, and more than likely it was always the same thing. Flat washer, lock washer, nut. And so we could ship big bags of hardware versus individual for each section. And what that did is, one, when they lost it, because inevitably you lose it in the field, it was easy for them to go get down the street at any Fastenal or anything like that and didn't cost a fortune. But number two is, if they just grabbed a bolt, they didn't have to worry about, is that bolt meant to go in that hole? They could just assemble everything and bolt it all together. And then the big thing that we're going to talk about here in a second is the right tools for the right job. Now, as I mentioned, when we were using Solidworks, most of the people have been trained to do it the traditional way of I make parts and then I make assemblies and I put it together. And that was left over from the previous group as well that were using Autodesk, AutoCAD, and Inventor in there. They were doing it that same way. And when we start looking at, 50,000 part assemblies, we all know that we have to find different ways to speed up performance. So we looked at it as, if we're going to build these as standard blocks and have all the detail, because the key is in the quoting process, we want to have as much detail as possible. Can we lighten them up? Because if I make always the same things, I'm not changing the drawings. They're always the same. So by going to multi-body helped us. It also helped us when we needed to create the custom sections. Because it was a multi-body, I could just do simple cuts in the subparts for what was unique. And then can we do less with more while improving communication? One of the challenges we had with installers is when you get to 50, 60,000 part assemblies or 100,000 part assemblies, and someone calls and says, hey, I put this where the dimension says, but the building's out of square. So I need a new dimension to ensure that I'm setting this right, because there's 10 other conveyors after this that all align to this one. So being able to verify and quickly take dimensions and share that with them sometimes would take hours. By the time you would open it up, you'd get it resolved, you'd go over here, you'd do XYZ, ABC. And meanwhile, the install team is on the ground waiting for this dimension. Sometimes they get impatient and they don't wait and they just set it. And if it's wrong, then they charge you again to go back and set it where it's at. So we looked at a scenario of, as a small group, we've streamlined the manufacturing process, but now we want to streamline the quoting process even more. We went from weeks to days. Let's see if we can go from days to hours. On the back end, where the rubber meets the road, right, and there's back charges and things, it's a scenario of how can we communicate effectively with the field, but also very quickly give them the answers they need so we don't get those back charges. And that's where we went through the process of evaluating lots of things, and we ended up at the 3D Experience platform with doing layouts, because what we found was we have all these standard components. So when we do layouts, we just take our 10-foot blocks and we drop them in and we do that what if. But on top of that, we may need to do the what if within a factory. And when we're doing the quote and layout, as I mentioned before, we would lay out all the standards. We'd take whatever the gap was left. We'd measure that, and then we'd just make a unique custom one. So in the order, the only custom numbers were the custom sections. Otherwise, the ordering process was always the same standard SKUs. So it gave us a way to designate it. We could also color it, but we could quickly use that within a big facility. And we don't build generally, in that time, we didn't build conveyors in a vacuum. It wasn't like, oh, hey, here's just one little pretty conveyor. It was, we got to make sure the conveyor fits with 50 other things and also fits the building and the height and the clearance and the walls, and can we get a forklift in there, and can we do all this stuff? And so you were never just building in a vacuum. So this is an example of a layout that would have been done. And you can, what was interesting is if you look at the basic sections like up here, these were pre all of the changes. And this is how you would see most recycling layouts from most manufacturers. They do these little Lego block dumb shapes where it's just rectangles, openings, squares, things like that. And what we found was by implementing the standards that we had, finding the right tools for the right job that could handle the large amounts of data, such as Virtual Factory Standard or Virtual Factory Professional, what we found was we could now take our fully detailed objects that are the production ready ones, drop them in the layout, and then showcase what it's going to look like, have the quote where it needs to be, and then quickly and easily just fill in the gaps of what wasn't standard. So if you look at the original ones that were done in 2D and 3D in the old school, it looks very simplistic and you have to do lots of guessing, right? Like, where do the legs go on this? I don't know. They're there somewhere. But when we went to this new method of standardizing our custom, you can see over here, all the data is there. The legs are there, the bolts are there, the railings there, the handrail is there. All of the detail of how we produce it is there. Because I can open this up in a couple minutes and work with it inside of the right tool for the right job, which in this case, and way back then, was our plant layout, our virtual factory. And that gave us the ability to do two things. One, when we quoted, we could quote quicker because we had the performance that we needed. Oftentimes in a couple hours, we could have a discussion with a customer. We could do a web call like this. We could show them, they could be like, okay, I don't like this, I don't like that. We could quickly just drop out some standard blocks, drop in some new, make a couple quick adjustments, and send them back over an update. And people were floored by the ability we could do that when most of the competitors were spending weeks to do a revision change because of not using the right tool for the right job. The other thing that happened was when you're often selling big municipal projects like this, you're talking to people that they don't visualize a space very well. So if you were to come in and like actually take a close look at this, you start showing the handrails, you start showing the detail, you throw a little color in this and you show that, and the people that are running these municipalities are like, oh wow, okay, I now get it, I'm with you, I understand, I see how this is going to fit. So having this allowed us to be better on the sales side with the same amount of people, but then also create a better communication with the people post that are installing the components, because we could share this same level of information and detail and then quickly and easily provide dimensions from where it's supposed to be. So for example, in this facility, it's now twice as big, and to be brutally honest, there are conveyors that go through the building over into another section and then come back around, not shown in here. But when you start talking about that, where this is built in phases over 10, 15, 20 years, the legacy data is just as important as the full detail. The key is, as you move forward over 5, 10, 15, 20 years, it's more critical to have all the detail of what was built versus what we approximated with Legos. So hopefully that explains a little bit about the journey that I went on going through being quote unquote custom, but finding a method to standardize to improve communication, sales, manufacturing, engineering, and ultimately, the most important part, making our customers happy and give them a better experience. Again, like I said, most people think of me today as the manufacturing guy, but in a previous life, I spent a lot of time trying to solve these challenges. So hopefully this overview and explanation helps some of you. If you have any questions, always feel free to reach out. I love talking about different ways to solve problems, and thank you for your time.